Good afternoon once again. Welcome to session number 4. In this session, we have with us Dr. Tirath Prasad Sahu, Assistant Professor, NIT Raipur, and his topic is naive Bayes classifier and other algorithms. Dr. Tirath Prasad Sahu, sir, can I have your voice, please? Am I audible?
Yeah, ma'am, you are absolutely audible.
Okay, good afternoon, sir. Welcome to CSIT TTP 2021.
Thank you, ma'am. So I
Sir, you
just
can. Yes, sir.
yes, I'm audible now.
Yes, sir, you are audible.
Okay.
Yes, sir. Okay, so session is going to just start. Sir will share the PPT. Thank you, sir.
Okay, thank you, ma'am. Thank you all the coordinators of this particular program of faculty development program, which is sponsored by CSVTU and Atal. And I thank special thanks goes to Somesh Devangan sirs who have invited me to deliver my lecture here. And definitely, whatever the topics that I will discuss today, it is going to help you all if you are using the machine learning concept for your research or any project work, right? So directly I'm going to just share my PPT, as today I'm going to discuss the conventional classification algorithm, that is very popular classification algorithm. Generally you will find this particular classification algorithm in all the paper if someone is using the classifiers. So firstly I'm just going to share the PPT. Is my screen visible?
Yes, sir.
Okay. So I'm going to discuss the basic conventional classification algorithm of machine learning, which is known as snap-based classifier.
Sir, full screen. Full screen.
I think I have already done the full screen. Is it visible in full screen mode?
Yes, sir.
Okay. So myself, Dr. Tirath Prasad Sahu, I'm working as an assistant professor in Department of Information Technology, NIT Raipur, since April 2013. And before that, I'm the alumni of NIT Raipur as well. I have completed my BTech in 2009 in NIT Raipur itself, and PhD in 2018. So this is the outline of today's presentation. First, I will discuss the background of NAP-based classification algorithm. As NAP-based classification algorithm is based on the probability, so I will discuss some basics of the probability so that you are able to understand how it is going to work. Then probabilistic classification, because NAP-based classification algorithm involves the concept of the probability. So I will discuss probabilistic classification, as there are types of classification algorithm. Then we will briefly discuss the concept about NAP-based, its principle, and how it works in order to classify the samples that is given. Then we will see the examples as well, the small examples we will take, and we will solve that particular example using NAP-based classification algorithm. And there is the drawback of NAP-based classification algorithm as well, which is called zero conditional probability. So we will see what do you mean by zero conditional probability and how we are going to handle this particular problem in the NAP-based. Then we will summarize this particular the presentation of NAP-based classification algorithm. And if time permits, then I will go I will go to discuss the genetic algorithm as well, but if time permits. So coming to the background slide, so there are basically three types types of classifier that you can establish. First is that you can modify a classification rule directly. If my voice is not audible or any issue happens, so you just remind me so that I can rectify it. Okay, because it may happen, because while I am discussing I am not able to understand what is going on, so someone has to interrupt me in order to solve that particular issue. So here we are just having three types of classifier. So one is the model, which models a classification rule directly. Meaning is that suppose there are certain rules. If the first condition is true, or second condition is false, and third condition is true, then we will classify the particular sample in the first class or the second class or the third class, right? Before going to discuss these three types of classification algorithm, first I will tell you, because many of you are not aware where we have to use the classification algorithm, right? So for that, I will go to the basic concept of machine learning. What do you mean by machine learning? Then types of machine learning. So basically, what do you mean by machine learning? There is the machine. There is the machine. Machine means what? Generally, if we talk about the machine, then machine means, nowadays machine is computer, right? We are talking about the computer. But anybody has idea how computer works? So basically, we know that there is the computer, but how computer works, how computer performs the operation. So basically, there are two operations only, right? Or only one operation, you can say, that is the addition, or there is the shift operation. Based on these two operations, that is addition and shift operation, we will perform all other operations like subtraction, multiplication, and division. Maybe you have heard about this thing. But how? I mean, basically, there are two operations, right, that computer performs. So one is the addition, and second one is the shift operation. Based on this, we can perform subtraction, we can perform multiplication, we can perform division. Might be, if you are from the computer science background, you have already studied the subject computer organization, where you have already studied both multiplication and all, that is division algorithm or multiplication algorithm, right? So but how this addition and shift operation is performed? So this addition and shift operation is performed by, maybe you have heard about the full adder, half adder. Maybe you have studied this particular concept in the digital electronics, right? But how this half adder and full adder is made up of? To design this full adder and half adder, we must have what? We must have gate. We must have logic gates, right? And in order to have the logic gates, we must have transistor like NPN transistor or PNP transistor. And to have the transistor, to design the transistor, we must have register. Register means which is having which are capable of storing the data. 8-bit register or 16-bit register. Similarly, in order to store 1-bit data, we must have flip-flop, right? So I'm just going from actually the top to down. So to have a flip-flop, I mean, that is capable of storing 1-bit device, right? The flip-flop. So for that, what we have to, like we have talked about the transistor. Na? So how transistor is made up of? Transistor is nothing but made up of by semiconductors. And what are the semiconductors? Silicon, germanium, and all. So the basic element in order to design the computer is nothing but the semiconductor. And based on the semiconductor, we can design the transistor. And based on the transistor, we can design the flip-flop. And based on the flip-flop, we can design the logic gate. And based on the logic gate, we can design the full adder and all, and we can perform the operations. So can you know, because see, many of you already know that there is the number system, binary number system, octal number system, and hexadecimal number system. But in general, we will use binary number system. Why? I will tell you why binary number system is used. Because in binary number system, we are having only two numbers, that is 0 and 1, or yes or no, you can say. And it is very easy to differentiate 0 and 1 with the help of the electrical signals. Because ultimately, in order to run the computer, we must have a power in computer system. That is the electrical power. And electrical power is coming into the computer system, and some up and downs is going on, or the voltage or the power is going on. So certain there is the threshold of the voltage, and if electrical signal is above that particular voltage, we will call it as 1, and if it is below that particular voltage, we will call it as 0. So it is very easy to understand, differentiate 0 and 1. That is called machine level language. So all the operation are in the form of binary only, right? So that is machine level language, that is 0 and 1. So in this way, we have to perform the operation in the computer system. Whatever the algorithm you are having in the computer system, machine learning, any algorithm, all are converted into the binary representation. And with the help of the binary representation, we are performing the operation. Right now, coming to the machine learning, this is the main thing. And why we are using the binary system, because it has only 2 digits, that is 0. So the complexity is very low. If you are increasing the numbers, like we are talking about the octal number system, so in that we are having 8 digits. So it is very difficult to differentiate the different levels, because different levels can be differentiated using the electrical signal. So it is very difficult to set the threshold value. That is why we will use the binary number system. So coming to the machine learning algorithm, so in machine learning we have to give the training or learning to the machine, so that whenever the new data comes or unknown things are comes, it takes decision by itself. Right. So like whenever the particular person is recruited for a particular post, so first the training is given to him or her, so that he or she may perform that particular duty very well. Right. So like in mathematics as well, when we are in the school level, so how teacher teaches us that he explains one particular problem, numerical problem, then he gives the similar type of problem, and he just want to he just asks that you just solve it and give the answer, right, by using some formula and some step of operations, right? So in this way we have already solved the numerical problems. In the similar fashion here also in the machine learning, because machine learning is going to take the decision, based on the based on history, that is past data. So this particular behavior is modeled in terms of training and testing. Means first the training is given. So whatever the mathematics teacher teaches us, that is called training. And whenever he gives unknown problem for which the answer is to be evaluated or answer is to be identified, right? So that is called testing. So in the similar fashion in machine learning, we must have the data set, that is the historical data set, or you can say the training data set, by which we will give the training to the machine. So basically in machine learning, always we are having the data set by which we have to give the training to the machine. That is called machine learning. So machine learns many things about the data set. Whenever the data set is fed to the machine, that machine learns many things about the data set based on certain algorithms. We'll talk about that particular algorithm based on certain algorithms. There are many algorithms. Algorithm means what? Set of rules. Algorithm means what? Set of rules that has already been defined, right? That has already been defined. So here what I am talking about is a machine learning means there is the machine learning. How machine learns based on the data set that we give to the machine, and based on that particular data set, machine learns many things. Just a second. So I have understood that I am going fast, so I will explain these things. Slowly. Okay. So what I'm saying, that there is the data set, and data set has to be given to the machine, so that machine learns many things about the data set, and based on that, it takes the decision whenever the unknown thing comes. Right. It's like we are the human, right? Whenever we see in the surroundings, if we are going in a particular path, right, and we are seeing that some vehicle is coming from that side, some vehicle is coming from that side or this side. So based on that, our mind takes the decision whether we have to stop, whether we have to take left, we have to take right, we have to move back. So based on the surroundings, whatever it is going on, we are taking the decision. In the similar fashion, machine also takes the decision. Whenever unknown data is fed into the machine, based on the history, whatever the machine has learned, based on that, the machine takes the decision, and this decision can be of any type. So there is the classification algorithm as well. So there are many problems are associated in real life, and there is the one problem that is called classification problem. So basically in machine learning we are having two types of learning algorithm. One is called supervised learning, and the second learning algorithm is called unsupervised learning. Yes, we are having semi supervised learning, right? But basically there are two problems. One is called supervised learning and unsupervised learning. In the supervised learning is nothing but the classification algorithm, right? And unsupervised means nothing but the clustering. So what do you mean by supervised? Supervised learning is that type of learning where already the labels are fixed. The class labels are already known. We are having two classes, that is binary classification algorithm. 3 classes, 4 classes or 5 classes, that is known as multi-class classification algorithm. I will tell you, people are not understood. They just know that either there is the binary classification algorithm or multi-class classification algorithm. Means whenever the problem is associated with more than 2 class, in that case the classification algorithm is known as multi-class classification algorithm. But no, only this binary classification and multi-class classification algorithm is not there. There is another type of classification algorithm that is called multi-label classification algorithm. Have you heard about the multi-label classification algorithm? Anyone? And can you give the example of multi-label classification algorithm? Because this is very important. Anyway, I will tell you what do you mean by this multi-level. In general, whatever the classification algorithm that you know is nothing but the single level classification algorithm. This binary classification algorithm and multi-class classification algorithm comes under single level classification algorithm. Why it is called single level classification algorithm? I will tell you. In single level classification algorithm, all the samples or the data, whenever I say samples or data point or rows, firstly I will tell you what do you mean by data set. If I am talking about the data set in the machine learning, so always you have to come with the structured data set. I am talking about data set. That data set must be structured. If it is not structured, then it is very difficult to understand the behavior of the data set for the machine. So that is why always whenever you are going to apply any machine learning algorithm, you just make sure that whatever the data set that you are going to fed into the machine, that should be in a structured format. Structured format means that should be in the tabular form, where it is clearly visible that what are the features, what are the columns. Feature means columns or the attributes, and what are the rows. Rows represent the data points or the samples. Right? In case of classification algorithm, the rows, tuples, or the data points are known as samples, for which class is known or unknown. In the training data set, class is known. For the testing data set, class is unknown. Okay. So again, what we do actually, whenever we take any data set for any purpose or from any field, maybe the data set is only one that is having many rows, many samples, right? So in order to evaluate our model or algorithm that we are proposing, you need to have two types of data set. One is training data set or testing data set. So in order to divide the data set into training and testing, there are basically 3 types. One is you may be having the separate data set for training and separate data set for testing. If you don't have like separate testing data and separate training data, so we can divide the data set into training data set and testing data set. How we can divide? Randomly we can divide. Suppose we are having 1000 samples in data set, so we can have 70%, that is 700 data in training data set and 300 data samples in the testing data set. Randomly we can take 300 samples for testing and rest is in training, right? That is random division of data set into training data set and testing data set. Second thing is that you may use n-fold cross-validation techniques. Someone may call k-fold cross-validation technique. What does it mean? That we can take the value of k is equal to 2, 3, 4, 5, 6, 7, 8, 9, 10. Suppose we are taking 10 because 10 is very popular. 10-fold cross-validation technique. So what do you mean by this tenfold? So what we do is we have to divide the data set into 10 equal parts, right? 10 equal parts. So we are having the 10 equal parts. So what we do is from 9 parts we have to give the training, and for one part we have to test it. Similarly, next time we have to take again the 9 parts, not that one. Suppose we have given the training from dataset 1 to dataset 9, and we have tested dataset 10. Now what we can do is we have to give from dataset 2 to dataset 10 as a training dataset, and we have to test from dataset 1. Similarly, dataset 3 to dataset 1, then we have to test dataset 2. In this way we have to test it, then we have to take the average of all the results, right, in order to quote it. Okay, so in this way we can have the training dataset and testing dataset. So the structured dataset is very important. So if many of you are doing the research, so what is the main contribution in the research? So what I am telling you, if you are taking the public dataset from means it is already in the structure format, so you have to give the contribution in the model section. Means ultimately you have to choose the problem of the existing model, of the conventional model, and you have to improve it in some way. Then only your contribution will be, I mean, given the weightage. Otherwise it is very difficult to get the publication. If you are not okay, if you are not, I mean, giving the contribution to the preparation of data sets, so you have to give your contribution to the model section, algorithm section. But if you are not, if you are just using the classification algorithm or existing clustering algorithm, so you have to, I mean, give your contribution to the dataset part. Like in my PhD, I have prepared the dataset for community question answering, right? I have taken the dataset from social sites, and I have prepared it as per the problem. It is not publicly available. So I have given the contribution into the data preparation also. So in that case, you may directly use the existing machine learning algorithm, right? And similarly, in the machine learning algorithm, many problems are there, starting from the preparation of data set, then processing of data set. Processing means pre-processing, maybe some noises are present, or pre-processing consists of feature selection and feature weighting as well. That is one machine learning problem. Then maybe the problem is associated with a clustering problem or classification problem, right? So in this way, you can give the contribution. So in this way, you may use the machine learning algorithm. So here, I'm just going to discuss the classification algorithm, that is supervised learning. Here, NAV-based is one of the classification algorithms. So if we talk about the classification algorithm, so classification algorithm can be classified in 3 categories. One, where we can model a classification rule directly. In this particular class, we are having KNN, decision tree, perceptron, SVM. Here, in all these 4 classification algorithm, what we do is we just model a rule for classifying the samples. In the next category, that is model the probability of class memberships given input data. Suppose there is the problem of binary classification, right? So what we do is, in that case, we have to identify what is the class membership. If we are taking one sample, so we need to identify the class membership of that particular sample to the class level, a particular class level. So we have to model the probability of class memberships given input data. Whatever the input data we are having, we have to look into the input data, and we have to model the class memberships of input data to the different classes. So for example, perceptron with cross entropy cross. Similarly, in the third category, we are having make a probabilistic model of data within each class. For each class, there are certain samples in the data set. So based on for each and every class, we have to apply the probabilistic model. We have to apply the probability concept into the samples of each and every class of the given data set. So that type of model is known as probabilistic model. So probabilistic model is having whatever the classifier that comes under the probabilistic model, that is associated with the concept of the probability. So here you can see A and B are examples of discriminative classification. Here A and B are the example of discriminative classification, and C is an example of generative classification, and B and C are both examples of probabilistic classification, because both B and C involves the concept of the probability. Okay. So here you may ask the question that what do you mean by discriminative classification and generative classification? So I will tell you what do you mean by discriminative classification is. So in the discriminative classification, it draws a boundaries. Okay, in the discriminative classification, it draws a boundaries in the data space. Okay, in order to discriminate the particular data, whether it will be classified in class 0 or class 1 in case of binary classification algorithm, right? So while generative models try to model how data is placed throughout the space, because in discriminative classification already the boundaries are drawn, and based on the boundaries, if the particular data sample falls in the left hand side of that particular boundary, so maybe it is classified into class 0. If it is falling into the right hand side of that particular line, maybe it is classified as class 1. But this is not the case with the generative model. In case of generative models, it tries to model how data is placed throughout the space. So a generative model focuses on explaining how the data was generated, right? How the data was generated, while in a discriminative model, it focuses on predicting the labels of the data. So I will tell you after telling the certain concept in the next slide how it is associated with the conditional probability and the joint probability, because in all the probability whatever I have discussed here, that is I mean the discriminative classification and the generative classification, because both involves the concept of the probability. So after explaining this particular basics of the probability, it is easy to understand what do you mean by discriminative classification and what do you mean by generative classification. So before clearly explaining what is the difference between discriminative and generative based on the concept of the probability, first you need to understand the concept of probability. So I think all of you have gone through the concept of the probability, but I'm just revising it. What do you mean by a probability? How we can find out the probability? What are the types of probability which is associated with this particular NAP-based classification algorithm? So first thing is that prior probability. There is the event X, and we need to find out happening that particular event X, probability of event X. Okay, then we are having the conditional probability. Suppose there are two events X1 and X2. So happening, what is the probability of happening X1 given that X2 has already happened, the event X2 has already happened. So here it is called conditional probability, right? X2 has already happened and we need to find out the probability of happening X1. That is called probability of X1 given that X2. Similarly, probability of X2 given that X1 means X1 has already happened and we need to find out the probability of X2. Then we are having next probability called joint probability, means happening of both the events jointly. That is probability of happening X1 and X2 simultaneously. Okay, what is the joint probability? What is the joint probability? Joint probability means what is the probability of happening X1 and X2 simultaneously. Okay, then what is the relationship between these two? That is conditional probability, joint probability, or prior probability. So the relationship is that probability of joint probability of X1 and X2 is equals to probability of X2 given that X1 into probability of X1. This is one formula, or probability of X1 given that X2 into probability of X2. Okay, this is the second one. This is the relationship between the prior probability, conditional probability, and joint probability. You need to remember this particular equation, right? The relationship between the prior probability, conditional probability, and joint probability. Now, next thing, that is independence. This is very important because we are going to discuss the concept of NAP-based classification algorithm, and this NAP-based classification algorithm is based on base rule, right? And there is some assumption. So that is why we need to discuss this particular thing, that is independence. When we call that both event and X1 and X2 are independent, when we say that these two events are independent of each other, we can say that X1 and X2 are independent of each other if probability of X2 given that X1 is nothing but probability of X2, or probability of X1 given that X2 is nothing but probability of X1, or probability, that is joint probability of X1 X2 is equals to probability of X1 into probability of x2. If any of the condition is satisfied, then we can say that x1 and x2 are independent of each other. Okay, this is very important. I am going to use this particular independence assumption in NAP based algorithm. Okay, so you just remember it. Then I need to discuss the base rule, because NAP base is based on the base rule. Okay, so basically here maybe you have gone through the base rule where it is represented by A and B, but here I have represented this A and B with the help of C and X. What do you mean by C and X here? Actually, C is nothing but the class label and X is nothing but the data set. Okay, the particular data, you can say particular row, and if we are talking about the particular row of the structured data sets, so that has many columns, that is many features. So you can represent X into X1, X2, X3, X4, X5. What is this X1, X2, X3, X4, X5? In this case, it is feature. Okay, it is feature. And what is C here? C is the class label. C may be C1, C2 for binary classification. For multi-class classification, maybe C1, C2, C3, C4, C5. Okay, so if we talk about ultimately what we have to do is in the classification algorithm, we need to find out the class level of unknown data, right? So unknown data X is given here. Okay, this X is unknown data is given. We need to find out its class, right? We need to find out probability of class given that X, given that unknown data. This is the main thing now. So that is why I have represented A, B in the form of C and X. So we need to find out the probability of class for unknown data X. So according to the base rule, probability of C given that X is equals to probability of X given that C into probability of C divided by probability of X. I will tell you this, we need to find out the posterior probability, that is nothing but probability of C given that X, that is called posterior probability. But how posterior probability is calculated, and based on the posterior probability we can predict the class level of unknown data. Okay, we can predict the class level of unknown data based on the probability of C given that X. So we need to ultimately we need to find out the posterior probability. This posterior probability is defined in terms of likelihood, prior and evidence. So this probability of X given that C is nothing but the likelihood. This probability of C is nothing but the prior probability, and this probability of X is nothing but the evidence. I will discuss what do you mean by this likelihood, and prior probability and evidence. So actually if we talk about, I mean this likelihood, prior probability and evidence and posterior probability. So first of all, what do you mean by posterior probability? Because based on the posterior probability we are going to find out the class level of unknown data. So posterior probability is the probability that your hypothesis is true given the observed evidence, okay. This is nothing but the posterior probability. And what do you mean the likelihood? The probability that the evidence is true, that is training data set we are talking about. Here you can see that probability of X given that C na. So in the training data set we already know na class level of each sample in the training data, right? So that is why a likelihood can be defined as the probability that the evidence is true, I mean the class is true, and given that your hypothesis is true, that means we need to find out this particular likelihood, that is probability of X given that C from the training data. Because without giving the training you cannot predict the class level of unknown data. So here we need to calculate the posterior probability based on the likelihood. And what is likelihood? Likelihood is nothing but the probability of known samples, given that class level, okay. Then what do you mean by probability of C? So from the training data you can easily find out, suppose I'm talking about the binary classification algorithm, right? 0 and 1. So you can easily find out what is the probability of 0 and what is the probability of class level 1 from the training data set. That is called prior probability. I'm just explaining in a simple word because it is very difficult to understand in terms of evidence, hypothesis, and all. Right? If you find out the, the definition of all these things, that is posterior probability, likelihood, prior, and evidence, maybe you are going to confuse. That is why here what I have written, that you need to find out the probability of class level for unknown data set. That is the main job, and that can be predicted based on the likelihood, prior, and evidence. Ultimately, evidence is going to be not going to be changed, so we will equate posterior probability is directly proportional to the likelihood into prior, because evidence is not going to change. It is same for all the class level. Okay, so ultimately this conditional probability, that is probability of X given that C, you can find out this conditional probability from the training data set. That is why always we say that training is must. You have to give the training to the model. If you are not giving the training to the model, you cannot calculate this probability of X given that C and probability of C. So these two probability, that is likelihood and prior, that is probability of X given that C, and the probability of C is calculated from the training data set, and that will be applied and that will be used whenever in the testing data set unknown instance comes. We can easily find out the class level of the unknown data set, that is probability of C given that X. Is there any doubt up to this? Because it is very important. If you have not understood this particular base rule, so you are not going to understand the NAP based classification algorithm, because these two concepts, that is the independence assumption, this particular equation, and the base rule, it is going we are going to use these two concepts in order to have the NAP based classification algorithm. So I am going to the next slide. So this is discriminative and this is generative, because based on the training data set, we will take one training data, second training data, third training data. So from training data set, there are training data, right? So based on the generative model, we can easily find out this conditional probability. So this is generative actually. So before going to the NAP based classification algorithm, I'm just giving the one numerical problem so that you can easily find out, you can easily understand what do you mean by prior probability, what do you mean by conditional probability, and what do you mean by joint probability. So there is the quiz, there is the question that when you are sure that you have already understood the prior probability, conditional probability, and the joint probability, you can easily understand the base rule and its independence assumption. Then we will go to the NAP based classification algorithm. So there is the numerical. We have two 6-sided dice, right? We have two 6-sided dice. There is the dice as shown in the image. There are two dices where we are having 6 faces, right? And in all the cases, what is written in 1 dot, 2 dot. So you are familiar with the dices. There are 6 faces of dices. So we are having two 6-sided dice, and what we are doing is we are just tossing these two dices simultaneously when they are told, and that means we are tossing up these two dices simultaneously. Then it could end up with the following occurrences. So there is the A, event A, or the outcome A, you can say outcome A. Dice 1 lands on side 3. So there are 6 sides, side 1, side 2, side 3, side 4, side 5, side 6. Similarly for the second dice as well, we are having side 1, 1 dot, 2 dot, 3 dot, 4 dot, 5 dot, or 6 dot. So 6 possibilities for one dice, similarly 6 possibilities for the second dice, and we are simultaneously tossing up. Okay, so we are just tossing these two sides simultaneously. So what happens that dice 1 lands on side 3 and dice 2 lands on side 1. What is event A? Event A is saying that, or outcome A is saying that dice 1 lands on side 3, and what outcome B is saying that there is another outcome. Outcome B is saying that dice 2 lands on side 1, and there are third outcome that is called as C, 2 dice sum to 8. So 3.
Excuse me, sir.
Yes.
Sorry to interrupt you, sir, but many of the participants are requesting to full screen the slide.
I think I have done the full screen. It is not visible.
Sir, no, sir. Please do it on slide mode.
It is already in the full screen mode. Now it is in the full screen mode. You just check that. See, because in my system it is in full screen mode. See.
Oh, good afternoon, sir. I think you have not selected the entire window.
Yeah, I have selected only one window that I am presenting
So,
here.
sir, please select entire window
Okay,
and
okay,
then
okay.
go to the full screen.
Okay, I'm just doing it. Just wait.
आ जाएगा, अब आ जाएगा.
So now it is visible.
It's visible.
Yes, sir, it is
Okay.
visible, sir.
Okay, so I am just discussing this particular slide. Here one quiz is given. We are having two six-sided dice, right? And we are just tossing these two dice simultaneously. So whenever we toss these two dice simultaneously, three outcomes are given: outcome A, outcome B, and outcome C. So outcome A is saying that dice 1 lands on side 3, dice 2 lands on side 1, and the C outcome is saying that 2 dice sum to 8. So if three outcomes are given, we need to find out all these following probabilities: probability of A, probability of B, probability of C, then probability of A given that B, probability of C given that A, probability of A comma B, that is joint probability, then probability of A comma C. Then now you have to check whether probability of AC, that is joint probability of AC, is equals to probability of A into probability of C or not. So you have to do it by yourself. So 5 minutes I am just giving in order to calculate all these probabilities, because it is very important to understand, because here probability of A, probability of B, and probability of C is called prior probability. Probability of given that B, probability of C given that A is called conditional probability. 6 and 7, that is probability of A comma B, and 7 is that probability of A comma C is known as joint probability. And based on that you have to verify that whether the joint probability of A C is equals to probability of A into probability of C or not. So you just do it by yourself. I am also doing parallelly so that you may understand. For that I am just going to open. So you just do parallelly. I'm also going to do that parallelly. Okay. So maybe it is visible to you that particular matrix 6 by 6 tables I have taken. Okay, why 6 by 6? Because in one dice there are 6 possibilities. Okay, in one dice, suppose I am talking about dice 1. So dice 1 may land either in side 1, side 2, side 3, side 4, side 5, and side 6. So ultimately, similarly for dice 2 as well. So how many possibilities are there? The outcome may be either 1 1, 1 2, 1 3 up to 1 6. Similarly, 2 1 2 2 6 2 6. Then similarly up to 6 1 6 2 up to 6 6. Okay. So here I am just writing it as, suppose 1 1, right? 1 comma 1. It may land. This is the one possibilities. Okay. Similarly, maybe it is visible to you. Then the second possibility may be, if dice 1 is landing on 1, so there are 6 possibilities, no? So it may be 1 2, then we may have 1 comma 3, then we may have 1 comma 4. It is very simple, but it is very interesting. You should understand. Then only we can understand. If we don't understand the concept of the probability, you are not able to understand the concept of best classification algorithm. Okay, so that is why it is very essential to understand it. If dice one is landing on side 1, so there are 6 possibilities. Okay, first argument is for, or first output is for dice 1, second is for dice 2. Okay, so the if dice 1 is landing on side 1, so there are 6 possibilities, either 1 1 1 2 1 3 1 4 1 5 1 6. In the same way dice 1 is landing on side 1, side 2, then we have again 6 possibilities like this. Similarly, we may have, if dice 1 is landing on side 3, then again we have 6 possibilities like this. Similarly, if dice 1 lands on side 4, then again we have 6 possibilities: 4-1, 4-2, 4-3, 4-4, 4-5, and 4-6. Similarly, if dice 1 is landing on side 5, then again we have 6 possibilities: 5-1, 5-2, 5-3, 5-4, 5-5, 5-6. Again, if dice 1 is landing on side 6, so again we will be having 6 possibilities: 6-1, 6-2, 6-3, 6-4, 6-5, and 6-6. Okay. So these are the possibilities that we may have. If you are tossing up the 2 dice simultaneously one time, so out of these 36 possibilities, anything can come. Anything may come, right? Out of these 36, because these are the 36 possibilities. Okay. So now we are moving to the question for in order to calculate the probability of A. So what is A? Dice 1 lands on side 3. Okay, dice 1 lands on side 3. In all these 36 cases where dice 1 is landing on side 3, where? This one. Okay, these are the favorable cases, favorable outcome. Dice 1 is landing on side 3. So how many favorable outcomes are there? 6 favorable outcomes. So here we may write probability, just a second. Okay, probability of A is equals to the favorable one. Okay, I'm just inserting the equation. So the favorable is 6 and total is 36 is equals to 1 by 6. 1 by 6. This is the probability of A. Similarly, you may calculate probability of B as well. So what is probability? What is B? You have to see what is B. B is saying that dice 2 lands on side 1. Dice 2 lands on side 1. Where dice 2 lands on side 1, these are the favorable one. Okay, these are the favorable one. Dice lands on side 1. So total cases are 36. What are the favorable cases? 6. So that is 6 by 36, and that is nothing but 1 by 6. Okay. Then we are going to the calculate probability of C. So probability of C. What is C? C is saying that 2 dice sum to 8. 2 dice sum to 8. So in order to get the sum 8, we should have at least 3 in one dice. At least 3, not at least 3, at least 2. If we are having 2 inside 1, we must have 6 in dice 2. Right? So see, this is the favorable. That is 1. This is 1. Where that is the favorable. 2 plus 6 is 8. Similarly, this one is favorable. 3, 5, 4, 4, 5-3, and 6-2. So how many favorable cases are there? Favorable outcomes are there. That is 5. 5 by 36. Okay. So probability of C is nothing but 5 by 36. Now we need to calculate probability of A given that B. Probability of A given that B. Probability of A given that B. So in that case, probability of A given that B, so B has already happened. That means B has already happened. Then we have to find out the probability of A. So you need to again check what is B. B has already happened. Dice 2 lands on side 1. Dice 2 lands on side 1. We have to restrict now the search space or the possible outcomes to these 6 outcomes only, because B has already happened, and B has already happened. That is, total outcome is now 6. Okay, because B has already happened, and in that case we have to find out the probability of A. And what is the probability of A? Dice 1 should land on 3. You can check that. Dice 1 should land on 3, and B has already happened. That is, dice 2 lands on side 1. So that is, the total outcome is 6, and only the favorable is this one. Okay, that is 1 by 6. That means it is 1 by 6. Probability of A given that B is nothing but 1 by 6, because we need to find out the probability of A given that B, means B has already happened. Then we have to calculate the probability of A. Okay, the next, probability of C given that A. In the similar fashion, you may find out probability of C given that A. So now how to calculate probability of C given that A? So for A, you have to restrict. Dice 1 lands on side 3. Dice 1 lands on side 3. That means this one. We have restricted our search space or the possible outcomes to according to the event A. So A has already happened. That is, dice 1 has landed on side 3. Then we need to find out the probability of C. So what is probability of C? Probability of C, or what is event C? Event C is nothing but 2 dice sum to 8. 2 dice sum to 8. Where out of these 6 cases, where we are getting some 8, that is only one thing, that is 3, 5. That is it. That is, again, it is 1 by 6. Probability of C given that A is also 1 by 6. Next probability, joint probability. Probability of A comma B. Probability of A comma B. A comma B. We need to find out probability of A comma B. That is joint probability. Means we have to see where A, that is A is happening and B is happening simultaneously. Simultaneously. What do we mean by A? Dice should land on side 3. Similarly, dice 2 should land on 1. That is 3, 1. Total cases are 36. 36, and only one is the favorable one. That is 3, 1. 3, 1. Okay, this one. And total, anything can happen. That is why total outcome is 36, and only one is favorable. That is 3, 1. So this is nothing but 1 by 36. 1 by 36. Okay. Then we need to find out the next one, probability of A comma C. So A and C.
Sorry to interrupt you, sir.
Yes.
Sir, the slide of the PPT is not changing.
I have already, shared the entire screen. So why it is not changing, I don't know. Exactly. I'm just rectifying it. Okay. Again, I'm stop presenting it. Then again, I'm sharing
Okay,
my
sir.
entire screen. See, this slide is visible, not in full screen mode, but in this mode. Is it visible?
No, sir, it's not visible.
See, this word document is visible.
Sorry, sir.
This word document is visible.
No, sir, it's not visible. It's not showing anything.
Now,
So just wait a second, maybe it will come. It's not showing, sir.
so whatever I have explained earlier, right? I mean, probability of A, B, C. I think it is not seen by the participant.
Yes, sir, it's not visible.
Okay. Now, you just confirm it whether it is changing to Word document in slides or not. Otherwise, I have to leave the meeting. Then again, I have to join the meeting again because I'm doing that one.
So that one is better.
Okay. Just confirm it whether slide is visible or not.
No, sir, it's not visible.
Yeah, someone is saying right. I think organizers can share the slide from their end. Actually, I am
Sorry,
sharing
sir.
the screen from my end, but I don't know why it is not changing or not visible because
Sir, I think
earlier
your
whatever lectures I
PPT.
have taken, it is okay, but right now I don't
Sir,
know why it is happening.
Sir, I think your PPT is in compatibility mode.
Okay.
So you just close your PPT and then
Oh,
again.
just wait a minute. I'm just stop sharing it. Okay. So whether I have to give the PPT to you?
Yes, sir. You can mail me.
Okay. Just give your mail ID because I don't have your mail ID. I can share in the, the Somesh answer.
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
Uh, Hello, ma'am. I think now my slide is visible. I think so.
Yes, sir. Now it's visible.
Now I think it is changing as well.
Yeah, yes, sir. It's changing.
Yeah, that is problem from my side actually. Actually, my internet got slower that time. That is
Okay.
why it is not changing actually. So now I have
Now
rectified
it's
it.
fine, sir.
Okay.
Yes, sir. Now it's fine.
Okay, so whatever I have explained, again, I am quickly explaining it because it is very important that the question is that we have to toss two dice simultaneously. So we have tossed it. What is outcome A? Dice 1 lands on side 3, dice 2 lands on side 1, and 2 dice sum to 8. That is the outcome A, outcome B, and outcome C. So we need to find. So what I have done is here, I have included all the 36 possibilities. First argument is for outcome of dice 1, and second argument is for outcome of dice 2. So these are the possibilities: 1 1 1 2 1 3 1 4 1 5 1 6, similarly up to 6 1. What is A is nothing but getting 3 on dice 1. So getting 3 on dice 1 is nothing but this one. These are the favorable one. In all these 6 cases, we are getting 3 on dice 1, and total cases are 36. That is why probability of A is nothing but 6 by 36, which is nothing but probability, that is 1 by 6. And what is B? Dice 2 should land on side 1. Dice 2 should land on side 1. So that is why these are the favorable cases. That is 6 by, again 36, totals are 36. That is why this is 6 by 36, and the probability of B is nothing but 1 by 6. And what is C? C is nothing but the sum of both the dice should be 8. So 8 is nothing but, these are the favorable: 2 6, 3 5, 4 4, 5 3, and 6 2. These are the favorable cases. These are in number 5. That is 1 2 3 4 5, and total are 36. That is why it is 5 by 36. Then we need to find out probability of A given that B. Meaning is that B has already happened, and what is B? Dice 2 should land on side 1. So these are already happened. So total cases are 6, and favorable is only 1, because we need to find out A. And A, what is A? Dice 1 should land on 3. So that is why these are the favorable cases. That is only 3 1, and these are the total cases. That is why it is 1 by 6. Similarly, we need to find out probability of C given that A is dice 1 should land on 3. So these are the favorable one. It has already happened. So 6 cases, total 6 cases are there, in which only one is favorable, which is nothing but 3 5, because C is nothing but about sum to 8. So only one, in one case we are getting 8. So that is why it is 1 by 6. Probability of C given that A. Now we need to find out joint probability of AB, means both the outcomes should come simultaneously. That means A and B. And what is A? Dice 1 should land on 3. So this one. And what is B? Dice 2 should land on side 1. So both the cases, in how many cases we are getting both the outcome? Only this one, that is 3 1. Right? So total cases are 36, and only one is favorable. That is why probability of A comma B is nothing but 1 by 36. Now probability of A comma C. A is nothing but dice 1 land on side 3. So these are the favorable as per outcome A. But as per outcome C, where we have to get sum as 8. So which is favorable? Only this one is favorable. So again, this is 1 by 36. Now the last one. Whether PA, joint probability of A and C, is equals to PA into PC, you just check that. Whether it is PA into PC, A into C, A into C, 1 by 6. A, probability of A is nothing but 1 by 6, and probability of C is nothing but 5 by 30. Whether these two are same? No, it is not same. Right? If we talk about, C, if it is equals to probability of A into probability of C, that is 1 by 6 into 5 by 36. It is same? No, it is not same. You can check that. These both are not same. No? So it is not equals to. That means if it is not equals to, that means A and C are dependent. If it is equal, then A and C are not dependent. Okay. But in this case, probability of A comma B, whether it is equals to probability of A into probability of B? Yes. 1 by 6 into 1 by 6 is nothing but 1 by 36. That means A and B are independent, but A and C are dependent. Okay. That is the meaning. And you can check that. A, what is A? A is coming 3 on dice 1, and C is getting sum as 8. Yes, both are dependent. Both are, why both are dependent? Because getting 8 depends on what is coming on A. What is coming on A? What is coming on A? Okay. So that was here event A and event B, or outcome A and outcome B are independent, and outcome A and outcome C are dependent. That is the main thing. Okay. So this slide is over. Now I am giving it to the full screen mode and going to the next slide. Now coming to the probabilistic classification. So we have discussed two types of classification. One is discriminative, another is generative. Okay, one is discriminative, another is generative. So in case of discriminative, ultimately we need to find out the class level for unknown instances. Unknown instances means the data set of the data points of testing data set. So here X testing data set, X is one testing data, and we need to find out its class level. Okay, and suppose there are L class level, L classes are there, and here X is equals to X1 to Xn. So what we need to do is we need to train a discriminative classifier, because maybe the classifier is discriminative or it may be generative. So to train a discriminative classifier, regardless its probabilistic or non-probabilistic nature, all training examples of different classes must be jointly used. Means whatever the training examples we are having, training data points we are having in the training data set, all must be given to the model. All must be jointly given to build a single discriminative classifier. Single model is there that learns all the training examples, jointly, and it gives L probabilities. After learning, it gives the single model, it is giving L probabilities with respect to each and every classes, because L class labels are there. That is why it is giving, you can check that it is giving probability of C1 given that X, probability of C2 given that X, probability of CL given that X. Means with respect to each and every class label, after giving the training, the discriminative probabilistic classifier gives L probabilities with respect to each and every class label. Okay, so output L probabilities for L class labels in a probabilistic classifier, while a single label is achieved by a non-probabilistic classifier. So this is what discriminative classification is. Whatever this probability is higher, we need to assign that particular class level to a particular example from the training data set. But what do you mean by generative model? That we are going to use in NAP-based classification algorithm. Here what we need to do is we need to find out the likelihood from the training examples that we have seen in the NAP-based rule. In this slide, you can check that here. Yes, this one, probability of X given that C. This probability is to be determined while giving the training to the model. Okay, so what we do is, yes, we need to find out the conditional probability, that is probability of X given that C from the training data set. Here again, the class levels are L class levels are there, and these are the training data set, and training data sets are there, and examples are there. So what we do is, with respect to each and every class level, we should have, suppose if class levels are L, so we should have L models. And just see the first particular model. This model is only applicable for class 1. So whatever the examples we are having in the training data set for class 1, that is to be learned by this model. Rest data points of the training data set is not to be learned by this model. That is why whenever we are having classification algorithm, if 5 classes are associated with the data set, we should have five generative probabilistic model, and that generative probabilistic model is with respect to each and every class. So for class 1, we need to give only those examples that is associated with class 1 label. Okay, so in this case, we should have L probabilistic model with respect to each and every class level. And based on that, each and every probabilistic model gives the likelihood with respect to each and every class. Okay, so that is the difference between generative model and discriminative model. Okay, so L probabilistic models have to be trained independently. It is very important in case of generative model. L probabilistic models have to be trained independently. Each is trained on only the examples of the same level. I have already discussed. Okay, and output L probabilities. Yes, it is giving L probabilities. After you can check that probability of X given that C1, probability of X given that C2, and probability of X given that CL. Okay, generative means that such a model produces data subject to the distribution via sampling. Now, after doing this one, means after finding out the conditional probabilities, because up to this we can easily calculate probability of X given that C, and based on that we have to now take the decision. Okay, because we have already given the training, and through the training the model has learned the conditional probability and it has calculated the prior probability. That is probability of X given that C, and probability of C, that is prior probability. But probability of X is not going to change. That is why it is written that probability of C given that X. Ultimately we need to find out the class level of unknown data set, that is X, and it is to be calculated or determined based on the likelihood, that is probability of X given that C, which is to be calculated at the time of training while giving the training, and the prior probability, that is probability of each and every class associated with the training data set. Okay, that is directly proportional to the probability of X given that Ci, that is this one and this one. It is not going to change. That is why we are not considering it, because it is not going to change. Ultimately we need to find out the largest probability. Okay, so that is why we are just omitting it. So it is directly proportional to this one, okay, for all the class level. Now in order to find out the class level for the unknown data set, that is from testing data set, we need to apply maximum of posterior classification rule, which is known as map classification rule in map based classification algorithm. So what we do is, in the previous slides, based on the training, we have calculated all the conditional probabilities with respect to each and every class, and we have already calculated the prior probability for each and every class, that is probability of C, meaning is that probability of C1, probability of C2, probability of C3, and so on, that is probability of CL. So we have calculated it, and similarly we have calculated all the conditional probabilities from the training data set. If we have calculated these two terms, that is the conditional probability and class probability, we can multiply it and we can find out all the values with respect to each and every class. Suppose 4 classes are there, so we will get 4 probabilities. That is probability of X given that C1 into probability of C1. Then second is probability of X given that C2 into probability of C2. Third is probability of X given that C3 into probability of C3. Fourth is probability of X given that C4 into probability of C4. So we will get 4 probabilities. Among these 4 probabilities, whichever is higher, whichever is maximum, we will select the class level. Suppose X is one data point. X is one data point. For that data point, we need to calculate, we need to find out its class level. Class level can be any one of those 4 class, either C1, C2, C3, C4. So whatever these 4 probabilities we have calculated, multiplication of 4 probabilities, whichever is maximum, that is the class level for this particular X. Suppose C3 means probability of X given that C3 into PC3, probability of C3 is maximum among all 4 probabilities, meaning is that X is to be classified into class 3, which is nothing but maximum posterior classification rule. For an input X, find the largest one from L probabilities output by a discriminative probabilistic classifier, that is PC1X, PCLX. Assign X to label C asterisk if PC asterisk given that X is the largest. That I have already explained. Then they apply the map rule to assign the label. So this is what map classification rule in case of NAB. So see here, in the base classification, we need to find out this one, probability of C given that X, that is proportional to probability of X given that C, that is nothing but likelihood into prior probability. So what do we mean by it? X is the data point, but that data point is scattered into the number of features. Many columns are there, so that columns are nothing but X1, X2, X3, Xn. Okay, we can represent probability of X given that C like this. Probability of X1, X2 up to Xn. N features are there. So we can represent this particular term into this particular term for all the class level. Okay. Then difficulties. What is difficulty? Learning the joint probability is infeasible. That is very important. Learning the joint probability for all the features, because X1, X2, Xn, if you omit it, given that C, so that is nothing but the joint probability. But joint probability is very difficult because number of features are very high. So what we have to do is, in NAB-based classification, I have already told you class independent exemption. Okay, so assume all input features are class conditionally independent. This is the assumption made by the NAB-based algorithm. If you don't assume the features are independent of each other, it is very difficult to learn the joint probability. That is why in NAB-based classification algorithm, there is an assumption. Assumption is that all the features in the data set are independent of each other. Okay. If it is independent, then only we can use the NAB-base. Means NAB-base is designed in such a way that it is assuming that all the features are independent. But in reality, I will tell you, in reality, the features are dependent actually. It is not possible that all the features are independent. There is no relationship between the features. This is not the case. Somehow there is the relationship. That is why this is the assumption made by the NAP-based classification algorithm. In the later research, means the authors are proposing algorithms, the modifications of NAP-based classification algorithm by relaxing this particular assumption. Means they are maintaining the relationship between the features. So that is why they have given weighted NAP-based. Some concept they have used. I am not going to explain it. I know it, but due to time constraints, I am not explaining it. This assumption that the NAP-based has made, the authors are, means nowadays authors are relaxing this particular assumption by giving modification to the NAP-based classification algorithm. You can also do. That is one research problem. Okay, so see this particular conditional probability, that is probability of x1, x2, xn, given that c can be represented in terms of probability of x1 given that from x2 to c. It can be represented. Okay, with the help of this particular formula only. This particular formula only. Okay, NAP-based rule. So now if it can be represented like this, like see probability of a given that b, see probability of a comma b is what? Probability of a comma b is equals to probability of a given that b into probability of b. The same formula we have applied here. So it can be represented in this particular form. So we have taken probability of x1 and all other terms we have represented here given that x2 to c. But x2 to xn, it is independent. Na? So it is dependent, only x1 is dependent on c. That is why this from x2 to x1 we have omitted here. That is why it becomes probability of x1 given that c only. Because features are independent, we are assuming. That is why we have omitted x2 to xn. So it becomes probability of x1 given that c. And whatever the terms here we are having, x2 to xn, we have represented here. Now again, from x2 to xn, we are again taking x2 given that c. So in this way, we can represent this particular conditional probabilities into this conditional probabilities. Probability of x1 given that c into probability of x2 given that c up to probability of xn given that c. Now after doing this, now we can easily find out the multiplication with respect to each and every class. If one unknown data is coming, we can calculate this particular probabilities into probability of c. Suppose only two classes are there, right? C and C asterisk. So we can calculate probability A means attribute or x1 means attribute. Probability of A1 given that C asterisk into probability of A2 given that C asterisk up to probability of AN given that C asterisk into probability of C asterisk, that is prior probability. This is likelihood and this is prior. So we have calculated the multiplication, and similarly there is the class level C. This is another class. So similarly we can calculate all this probability, then we can compare these two probability, whichever is higher, which is nothing but the class level for the given unknown data set. Okay, that is the meaning. Now, as yes, in NAP base, in the data set, maybe the discrete, maybe the continuous value. In the data set, it may be discrete, it is maybe the continuous value. So first I will discuss NAP base for the discrete valued features. Okay, for the discrete valued features, whatever we have discussed, that is the main thing. So directly I am going to this particular example so that you can easily understand. Yes, you can easily understand this particular slide after going through this particular example. So here in this example, 14 examples are given. 14 rows are there. And how many features are there? Outlook, temperature, humidity, and wind. These are the features. And this is the class level, yes or no. Okay, 14 rows are there. 14 rows are there. This is training data set. Okay, first of all, this is training data set. In this training data set, 4 features are there. One is outlook, second is temperature, third is humidity, and fourth is wind. And last column is play tennis, whether play tennis will happen or not. Players खेल सकते हैं based on this environmental condition or not. So only 2 classes are, that is binary classification problem. So how we can apply NAP based classification algorithm for unknown? I have not given right now testing data set. I will give later on. So first of all, based on the training, we have to give the training to the model. That is the main thing. So by training to the model means calculating the conditional probabilities and prior probability. That is the only thing. In NAP based classification algorithm, giving the training to the model means finding it out the conditional probability and the prior probability, that is probability of x given that c into probability of c. That is we need to calculate. Here c is nothing but yes or no, that is probability of s, and probability of no is the prior probability. We can easily calculate because 14 rows are there. In how many cases we are having s? 9 cases we are having s. In how many cases we are having no? In 5 cases we are having no. So the probability of s is 9 by 14, probability of no is 5 by 14. That is prior probability. That is probability of c. probability of C1 and C2. We have calculated prior probability based on the training data. Now we need to calculate probability of X given that C. Okay, for that we need to design the lookup table, because you have to do it by yourself, but due to time constraint I am directly explaining this lookup table. So how lookup table can be made? For each and every feature we have to make the lookup table. We are having the 4 feature, so 4 tables we are having. First feature is Outlook. See, this is Outlook, and only 2 classes are there, so class 1 and class 2, that is play is equals to yes and play is equals to no. And in Outlook you can check that how many different values are there, feature values are there. Sunny is 1, overcast is 2nd, rain is 3rd. Okay, only 3 values are there. So with respect to Sunny, in how many cases we are having S for Sunny? So for Sunny, in how many cases we are having S? 1, 2. Red for S and black for no. So in Sunny, in 2 cases we are having S, and for the rest cases, because in how many cases we are having Sunny in Outlook? 1, 2, 3, 4, 5. In 5 cases we are having Sunny in Outlook feature, out of which in 3 cases we are having no, and 2 cases we are having S. So in 3 cases we are having no, in 2 cases we are having yes. But in 9 cases we are having in class level, that is why 2 by 9. In 2 cases we are having probability of Sunny given that S. Probability of Sunny given that S is nothing but 2 by 9. Probability of Sunny given that play is equals to S, because in 9 cases we are having S, so yes is given. In S is given in 9 cases. In how many cases we are having Sunny? That is in 2 cases. That is why probability of Sunny given that S is 2 by 9. Similarly, probability of Sunny given that no is 5, because in 5 cases we are having no, it is already given. In out of those 5 cases, in how cases we are having Outlook is equals to Sunny? That is in 3 cases. That is why it is 3 by 5. Similarly, probability of overcast given that S is 4 by 9. Probability of overcast given that no is 0 by 5. In no cases we are having no. There is no examples where we are having no Outlook is equals to no. Okay, you can check that. In the Outlook is equals to in the overcast, in no cases we don't have. In this case we don't have overcast. 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 So that is why 0 by 5. In all cases we don't have. That is 0 by 5, and that is why here we are getting probability 0. That is called 0 conditional probability. I will tell you later. This is the drawback. Okay, we will handle it. So in this way we can make the lookup table. This is for Outlook. Similarly, this is for temperature. This is for humidity. This is for wind. Is there any doubt in making this lookup table? And we have already calculated probability of S, that is probability of play is equals to, that is 9 by 14, and probability of play is equals to no, that is 5 by 14. So in this way you can calculate this is called prior probability, 9 by 14 and 5 by 14, and these are called conditional probability. This one is nothing but probability of Outlook is equals to Sunny given that play is equals to S. This is Outlook is equals to Sunny given that play is equals to no. This is Outlook is equals to overcast given that play is equals to S. This is Outlook is equals to overcast given that no. In the similar fashion you can calculate from this particular table all other conditional probability. Okay, now unknown data is given. It is not in the data set. X is given, X dash is given, where Outlook is equals to Sunny, temperature is equals to cool, humidity is equals to high, wind is equals to strong. It is not there in this data set, but here class level is not given. See in the data set how many columns are there? 1, 2, 3, 4. This is just 6 serial number, so this is not feature. 1, 2, 3, 4. 4 feature and 1 class level. 4 feature values are given, but class level is not given here, and we need to calculate its class level based on the training data set. Okay, now what you have to do is, see, Outlook is equals to any, this X dash can be classified in either yes class or no class, whether play can happen and play cannot happen. We need to find out, right? So for that, for S class, we need to find out a probability of Outlook is equals to Sunny given that S, that is 2 by 9 from the lookup table, 2 by 9. Okay. Similarly, probability of Outlook is equals to Sunny, play is equals to no. We can find out from lookup table, that is 3 by 5. Similarly, temperature is equals to cool, play S, temperature cool, play S, that is 3 by 9. So here we have taken 3 by 9. Temperature cool, play no. From lookup table, temperature cool, play no. 1 by 5. 1 by 5. In the same fashion, similarly for humidity, similarly for wind, we can calculate it. Now we can take, similarly play probability of play is equal to S, that is prior probability, here probability of no. We can multiply all these probabilities, 2 by 9 into 3 by 9 into 3 by 9 into 3 by 9 into 9 by 14. Similarly, we can multiply 3 by 5 into 1 by 5 into 4 by 5 into 3 by 5 into 5 by 14. So when we have multiplied all these probabilities, it is giving probability of S given that X. And whenever we are multiplying these all terms, it is giving probability of no given that X. See which one is higher, 0.0053 or 0.0206. This one is higher, 0.0206. It is associated with which class? No class. That means no class is for the unknown data set that is given, because probability of no given that X is largest one. That is why the class level for X dash is no. Is there any doubt? Because see, no one is going to tell you the numerical example for each and every classification algorithm, and I will tell you, whenever you are using any classification algorithm, first solve the example, numerical example, small numerical example, then you are going to understand. Otherwise it is very difficult. Now I'm moving toward the next, because here I have taken the discrete valued features. Now how naive-Bayes classification algorithm can be applied for continuous valued features? So for that, ultimately we need to calculate the conditional probability and prior probability. Only thing is that how the conditional probability is calculated. So for the continuous valued feature, this formula is applied, that is this normal distribution is used in order to calculate the conditional probability. There is a probability of X given that C, 1 upon root 2 pi sigma. What is sigma? That is the standard deviation. Okay, and what is X? X is the value, mu is nothing but mean, sigma square is the variance. If sigma is the standard deviation, then sigma square is the variance. Okay, so I will tell you how you can calculate it. Now learning phase is same thing. So what you have to do is, suppose that is the training data set. Now because for all the 14 cases, 14 data set in this particular table, for 14 data sets, suppose this is the continuous value feature. For S class 25.2, these are the 9 values. This is the continuous value. For no class, these are the continuous values. For which feature? Temperature feature only. Okay, for the temperature feature, suppose temperature feature is of continuous nature. All other features are outlook, humidity, and wind are discrete feature. So we can calculate, how we can calculate this conditional probability. So for that, we need to calculate the mu. Mu of what? We need to calculate the mu. Mu is nothing but the mean value. Sigma square, that is nothing but the variance. For the formula for the variance is this one. So we need to calculate mu S. So we can find out easily the mean of these values, S values, which is nothing but 21.64. Mu no, we can calculate from here. It is nothing but 23.88. Similarly, sigma S, we can use this particular formula in order to calculate sigma S. So sigma S we can calculate. These are the values. For that, we can calculate the standard deviation for S class. Similarly, standard deviation for no class. Once we calculate this mean value for both the classes yes, no, standard deviation for both the classes yes, no, we can put these values into this particular formula. And once we put this particular formula, we will get this equation. Probability of X given that X is nothing but this one. There is the X term. Similarly, probability of X given that no, this is X term. Now, how we can calculate it? Whenever unknown data is given, we can put that unknown data in place of X, and we can easily calculate probability of X given that S. Okay, that is the only thing. Okay, now zero conditional probability. So we have seen that in case of outlook is equals to no, we are getting 0. Overcast is outlook is equals to overcast, and play is equals to no, we are getting 0. Whenever there is any 0 term in the multiplication, the whole becomes 0. So this is the problem, na? If any term is 0 here, so we will get 0. Then there is the problem. It is not going to work, because if you are getting 0 here after calculating is that particular class level will not be considered if any term is 0. So we should avoid this type of cases. So that is called an estimate. So what we have to do is artificially we have to add that type of example, because we don't have this type of example where outlook is equals to overcast and play is equals to no. We don't have such example in the training data set. So in the training data set, we have to manually add that type of example to avoid this type of issue. right? So that is why here it is written. What it is written in these circumstances, we face a zero conditional probability, because if any probability is zero, the whole becomes zero. So again, we need to re-estimate this particular thing, that is M estimate, and it will be conditional probability will be estimated based on this particular formula, that is NC plus NP divided by N plus M. What is NC? Number of training examples for which Xj is equals to AJK. N is the number of training examples for which C is equals to CI, right? And P is equals to the prior estimate, M is the weight to the prior. It is explained based on the example. Probability of outlook is equals to overcast given that no is zero in the play trainee data set, and add M virtual examples, that is, it is called M re-estimate. If you see M estimate, okay, so M examples. So how many examples you have to add in order to avoid such type of issue? So it is given in general, you can add up to 1% of number of training example. So for the no class, how many training examples we are having? 5 training examples we are having. So 1% of 5 is very less than 1% of 5 is less than 1. So at least you have to add 1, because you cannot add 0.1, 0.2 in fraction. You have at least 1, 2, 3, 4 in integer only. Okay, so 1% of training example is nothing but 1. If you are taking the ceiling of it, okay, so you can add one virtual example where outlook is equals to overcast and the class level is no. So we can add one. Whenever you add one, so outlook feature can take only 3 values. So that is nothing but P 1 by 3. If you see, what do you mean by P here in this formula P? So P is 1 by 3. So how many different values are there for outlook? 3 different values are there if you see the data set: sunny, overcast, and rain. So that is why P is equals to 1. P is what? Different values. Okay. Then P is equals to overcast given that no is equals to 0. 0 is what? NC, number of training examples for which X is equals to AJK, that is outlook is equals to overcast. In how many training examples you are having outlook is equals to overcast, and class is no. So 0, that is why we have put here 0. Then in this particular example, what is M? M is nothing but weight to the prior. Weight to the prior. So how many M means we have given? That is 1. Only 1 examples we are going to add. Okay. Then N plus M. What is N? Number of training examples for which C is equals to CI. So 5 examples means for no class we are having 5 training examples. Then M, weight to the prior. How many examples you have added? That is only 1. That is M is 1. So here M is 1, here M is 1. So P overcast given that no is 1 by 18. So in place of earlier we have calculated P overcast given that no is 0. Now we are calculating after adding the virtual examples P overcast given that no is equals to 1 by 18. Now you can accommodate. So if it is changed, probability of overcast given that no is 1 by 18, it is also going to change. Probability of sunny given that no, because we are adding the virtual examples. After adding the virtual examples, all the probabilities related to the no is going to be changed. So again, we have to re-estimate that particular probability. So the probability of sunny given that no is 5 by 9, probability of rain given that no is 7 by 18. So we have re-estimated these conditional probabilities. After re-estimated, you can apply the same thing that we have already discussed. So now this is the summary for the NAP base. NAP base is nothing but the conditional independence assumptions we have made in order to devise NAP based classification algorithm. Training and test are very efficient. We have seen the 2 different data types lead to 2 different learning algorithms. Yes, working well sometimes for data violating the assumption. If we are, violating the assumption, whatever the assumption NAP base has made is that features are independent. If suppose there is the relationship between the features in real life, then also it is going to work. NAP base giving the good result. In fact, we are having the relationship between the features, and it is assuming that features are independent. In that sense, also it is giving the good result. So this is the popular generative model, that is NAP based popular generative model, performance competitive to most of the state of the art classifiers, because in many cases NAP based classification algorithm is used. Okay, even in presence of violating independence assumption. Many successful applications like spam mail filtering, a good candidate of based learner in ensemble learning, because in ensemble learning we can use many classification algorithm, many learning algorithm. So this is one candidate. NAP based classification algorithm is one candidate for ensemble learning. Apart from classification, NAP based can do more. So this is what NAP based classification algorithm is. Is there any doubt? Because due to some network issue, 10 to 15 minutes are lost. So we have taken 10 to 15 minutes more. So I have covered a very fast, I mean, last 4 to 5 slides. If you are having any doubt, you may ask. Anyone having the question related to the classification algorithm, general problems related to the classification algorithm, single level classification algorithm, multi-level classification algorithm, multi-class classification algorithm, related to the NAB base. So I'm happy to give you the answer if I can. And currently, my research team is working on one problem of machine learning algorithm, that is feature selection. That is very popular problem. Everybody using this feature selection problem. So you may go through my research profile from Google Scholar, where I have already published research paper along with my students, PhD students and MTech students. So you can go through it. And if you face any difficulty, or if you want to work in the feature selection algorithm, you may take the help from me.
Oh, thank you, sir.
Thank you, ma'am. I think no questions from audience side, because it's already late. I think so. That is why they are not asking the question, because they are hurry to take the lunch. I think they are hungry.
Okay, sir, just
Okay.
a minute. Dear participants, if you have any doubt, you can ask.
Rao sir has commented no, sir.
And
Okay.
feedback link and session link both are already shared in the chat box. So please
Thank you, Rao
submit
sir.
it within the time frame. Sir,
Yes, ma'am.
sir, please share your PPT.
I'm just sending it. Just be online. I'm just sending it.
Okay, sir.